As we think about this last part, for the interval from 0 to 9, what is the fewest number of times that r prime t must equal 0? And again, we've been told that rt is a twice differentiable function, so if we can take its derivative twice, then it must be continuous. And it must be differentiable, so it's going to be smooth. And so if I were to draw a nice smooth curve through all the points given, it doesn't mean that it couldn't do this. Go up and down and up and down. Of course it could do all that. But the simplest graph that we can draw is this blue one. Well, what would it mean for r prime to be equal to 0? Given that this is r, then that means r prime of t would equal 0. So we would have a tangent line with slope equal to 0. And we could have that here, somewhere here, somewhere in here. And if we had all those other humps that other graph had, we could have more than 3. But the fewest number of times is 3 times. So there's lots of different ways to prove this or to justify it, but they're all pretty tricky. One would be that you could say by the intermediate value theorem, and you'd want to say RT is continuous, because that's got to be true for the intermediate value theorem to apply. There must be a value between 7 and 8 such that RT is equal to 120 tickets per hour. This must happen between t equals 7 and t equals 8. Then, by the mean value theorem, the average rate of change between t equals 0 and t equals whatever the x value is that results in RT equaling 120, then the AROC must equal 0. That means that there are at least 3 locations such that r prime of t equals 0. That's one of the many ways that we could defend that there are 3 times where RT must equal 0 from 0 to 9.